hi everyone. Nice to be here, of course. Thanks a lot for inviting me to share some of my experience with these topics. First of all, and before starting, this is my LinkedIn profile. So if anyone has any questions that end up being unanswered, or if you want to talk about anything with me, I don't bite, I'm open. Feel free to add me here, and I will be glad to help you with whatever I can, or answer any questions you have, or just chat informally. So yeah, today I am here to talk a little bit about, let me move this away. Yeah. I am here to talk about my work in IFC.js, which is the work that I have been doing for the last 2 years, more or less. So the IFC.js is a free and open source framework to create BIM applications. And for the ones that don't know how to code, this simply means that is a bunch of code to create BIM applications without having to create everything from scratch. You have to understand that when it comes to code, it's just a set of instructions, right? And what happens in software development is that some people create code solving problems, and they make that code available to other people so that you don't have to go over those problems again. And this is really, really useful. For instance, imagine that you need to perform linear algebra operations or matrix operations or whatever. Of course, implementing the 4x4 matrix multiplication is pretty tedious. But if someone did that, maybe there's a library out there that you can simply import into your project and you don't have to go over that again. And for me, this is really what automation means. Automation doesn't mean solving a problem that you individually have to solve and make it automatic. Automation means solving a problem once and for all so that nobody has to solve that problem again, right? And this is a bit the philosophy that is behind this project. You know, in our industry, software is becoming more important. And in my opinion, we should already add the S at the end of the acronym: architecture, engineering, construction, operation, maintenance, and software. And the problem that we have with software is that it is not accessible. And when I say that it's not accessible, it's very easy to illustrate this looking at other industries like the video game industry. If you assemble a team of 2 or 3 people and you take a bunch of tools, you can probably easily make a video game in 1 weekend. And this is something that nowadays is impossible with BIM software. And this is not because BIM software is more complex than a video game. In fact, it's the other way around. A video game is way more complex than the software that we usually use for construction. The reason is that the technology to make video games is available as libraries, as game engines, and it's well documented that anyone can take that and they don't have to start from scratch, right? They have all the biggest problems of making a video game already solved. Problems like how to solve real-time physics collisions, how to solve, efficient and nice-looking rendering so that we have a realistic game. And we can take, there are many options out there. We can take any of them and create a video game easy, because all the hard problems that involve math, physics, low-level software engineering are solved, and we can just focus in making whatever adds value to our video game, which is, the story, the characters, the design, and so on. And the idea is, what if we had the same in the construction industry, right? What if we solved the biggest common problems in common in such a way that if tomorrow I wanted to make a clash detection tool, or if I wanted to make a modeling tool, whatever, I could simply take those pieces, the clash detection engine, the modeling engine, geometric engine, CSG operation engine, whatever, use that as a base to make something. And that is what I started doing when I started IFC.js. I started more or less in 2021, and basically is a, you could see as a starting point for making the equivalent of a of a game engine, but for BIM. It runs in JavaScript. I mean, the name is IFC, of course, because of the schema, and JS because of JavaScript is the programming language that it uses. And the reason that I chose JavaScript is because it's the programming language of the web. And all the web runs in JavaScript. And because this very representation is also in the web, it means that it's JavaScript, and I am able to create and embed a 3D BIM application directly inside the presentation. And I can open the file system of my computer, take an IFC file, open it easily, see the elements. And I was able to do that in 10 or 15 minutes, perhaps, because all the problems involving reading and parsing the IFC, creating an efficient 3D, this selection tool, I think that there might be, yeah, properties and much more are already solved, so that I can just focus in making this look cool and so on, right? So I started the project in, yeah, more or less 2021. It started growing, getting attention, and more people started to join. And at some point we realized that, you know, spending or thinking that you can change the world in your free time is a very, I would say, beautiful way of seeing life, but that's also very probably unlikely. There are examples of people that were able to create open source projects in their free time, and they ended up being successful. But the problem with those examples is that you always have the survival bias. You only see the projects that succeeded, you never see the project that failed, right? So we realized that we wanted to scale this and make this faster. So we took the community that we were building and we started raising money to accelerate all of this. And the way that we did that was actually very simple, because we were creating technology that was open and free. There was a demand on people for learning to use that technology. And we used the education as a way of raising funds with our community through the use of bounties. And bounties are basically the list of things that we need to do for the project. Instead of doing everything ourselves, we make the list public so that literally anyone can come and say, hey, you know what? I'm going to help you there. And that person gets money for it. And of course, that makes the technology grow, which increases the demand for more education. And that's what we have been doing for the last year. So this is the educational platform that we set up. Very, very basic. The plan for this year is to grow this a lot, but we were able to raise approximately a bit more than $200,000 in half a year, which is not too bad. The plan is to hopefully reach 7 figures this year. And yeah, we are basically making software developers inside our industry. We believe that it is very unlikely to cross our fingers and just expect IT experts to come from other industries and save us. We believe that at least to start with, the change will come from probably people from the industry that learn to code and get into software development. And software development in this case doesn't just mean making a Dynamo tree, it means proper software development with all the things that a full-time software developer job would require you to do on the web. Of course, we are specialized in the web. So we are teaching that. We have around 1,000 people learning. And this is the place for the bounties. And anyone can come here. This is updated and anyone can see, okay, what can be done? Where can I help? And anyone can get money for it. Of course, the easier tasks are less money, whereas some more complex tasks have a higher price. Fun fact, there was this guy, software developer, that worked at NASA that spent 1 weekend here, and he was able to make $3,000 helping us make complex things. So yeah, anyone can really help here. And we are very happy to spend all the money that we are raising back into the project and see it accelerate. the plan for this year is to apply this same system even further to make this grow and to hopefully gain some control over the more or less uncontrollable process of open source growing. The problem with open source is that because it doesn't have the resources that it would have if it was like a proper business with proprietary software, it relies a lot on people pushing the things forward. And yeah, we are really trying to, you know, control this by enabling people to make a living out of this, basically. And let's see where we bring this. Yeah, I mean, there's many things going on right now. For instance, like literally, I believe last December or last November, we announced that we were going to create an alternative to the cloud solutions like Autodesk Forge using this free and open technology, 100% open source. And we were asking companies, we were looking for 10 companies to participate in this project and to get involved to help us create a solution that would solve the problems that they had. And we got, I believe, 120 companies applying, and some of them were like really, really big. I think the biggest one was around 180,000 employees. So yeah, we have just selected the 10 companies. We will publish the list soon, and I'm sure that the list will raise some eyebrows because we're very happy with it. And now we will start working on this, and we will. The plan is to create this alternative to Forge, or it's not called Forge anymore. I know, but sorry, I'm just refused to change the name. In 6 months probably. So let's see how that goes. In the end, we see that what we need in our industry to change is the decentralization of software development. In other words, we cannot cross our fingers and think that individual companies are going to suddenly come up with this perfect solution that will solve all our problems for a nice price. Probably it's more likely that if we had something similar to what they have in the video game industry, which is anyone can create software. So you have many companies from many different sizes offering a wide range of products and having a very how can I say this? Having a high rate of iteration is what really fosters innovation, because if you have 1,000 companies trying 1,000 different things, it's more likely that suddenly one of the companies come up with the next big thing, right? And suddenly everyone is happy because we have something new, we have something that works better, and so on. And the only way that we think this can happen is through decentralization. And these are the two main obstacles that are between us and decentralization: the lack of developers. And again, here I'm not referring to perhaps someone that just know how to make a couple of scripts, which is fine, but I'm talking about people that make full-time software development, and the lack of technology, because even if we had the best developers in the world, it is very hard to develop BIM software nowadays because of the lack of resources that you would find in any other software industry, right? Like, if I wanted to become a video game developer tomorrow, I would have it very easy. I would have a lot of tutorials, a lot of courses, how to get started, what technologies do I have to learn. So yeah, and I mean, if you type in the web how to create, I don't know, an alternative for Revit, probably nothing will change. A lot of people will be saying things in forums and so on, but no course in Udemy, no clues whatsoever. And I think we can make it. I really think that this is something we can really achieve. I mean, not we as IFCJS, we as an industry. I think we can achieve this state of technology in a reasonable amount of time. And yeah, I mean, this is what we are doing now. We are making the community thing. We are doing the alternative to the cloud solution thing. Everything is open source, and still we are getting money just to make it faster and strong enough to have an impact. And yeah, I mean, I'm telling you a lot of things, but probably the guys, I mean, the people that are listening to me that have no previous experience with IFC.js, maybe you're wondering, okay, this is nice, but what can you really do with what you're doing so far? And here I bring some examples to show you the power of software decentralization. So in this case, this is an application that was developed by Parametricos, a BIM software development company. And they made this, they participated in this 48 hours hackathon. So it's like a 48 hours competition to make a software. And they won using this, let me see. Yeah, no, wait. Here it is. Maybe because I'm sharing my screen, the connection is a bit slow. Let me check. Yeah, here it is. So this is a 3D GIS and BIM application developed in a weekend. Let me change the time because it's night, so the sun is not visible. And if I can move this away, yeah, you will see that here I have access to a number of IFC models, and everything is being executed in Google Chrome in this case. And again, because I am showing you a presentation that is in a web page, and because all of this is JavaScript, this application that you're seeing is running inside the presentation, which is crazy, right? Like, because usually we see BIM software as something that happens in a desktop application, an executable that maybe takes hours to download and so on. But this is probably how the next applications will look like. Something that runs directly on the browsers, something efficient, powerful, that we don't need to install, and something that allows us to collaborate and be connected in real time, right? So yeah, this is basically this is an IFC model parsed and interpreted directly by Google Chrome in this case. And the city that you see around it, it's, I believe, San Francisco, using another open source library called HarpGL. So the combination of two libraries, IFC.js for the building and HarpGL for the city, makes it possible to develop these kind of things in 48 hours. Another example, in one of the courses that we made, one of the students, or some of the, we organized another competition of programming so that the students had like 3 weeks to develop something. And one of the students, which by the way works in CIMS, probably you're familiar, is Nico, developed this super nice application, bringing together GIS and BIM. And he was able to see the buildings in a city. He was able to cut the building, navigate around it. And he was able to do this completely for free. And yeah, I mean, this is not an end user application. This is something that he developed, and maybe he can sell it. Maybe he can use it internally for his company or university or whatever. So this is the power of not having to start from square one every time, of solving the common problems and then letting the people just make things or cool things on top of it, right? I'm talking a lot about the web because JavaScript is mainly for the web, but it's also for desktop. And in this example, I developed a desktop application in 16 lines of JavaScript. Maybe you don't know how to code, but probably you can imagine that this code is not a lot. And just making this, I was able to develop a executable using Electron, another open source tool that allows to create desktop applications with JavaScript. And of course, this application was super simple because it's 16 lines of JavaScript, but I was still able to get files from my computer, load them into the application, navigate them, And you can imagine that, of course, if I had spent more time making this, I would have more tools around. I could build a whole thing on top. And yeah, in the end, many times when we talk about BIM software, we talk about what possibilities do we have with the tools that we have on the table right now. But when you make the leap to BIM software development, it's more about what can I imagine? Because if you can imagine it, many times you can simply sit down, investigate, spend time, and make it, right? Like we could do anything. We could make energy simulation. We could make structure analysis, many things. Another example by Yassine Walid from Sigma Dimensions, using an IFC that had 4D information, he was able to generate these very nice charts directly in a web application loading IFCs. Another example, in this case, from another person that participated in one of the hackathons that we organized for one of the courses that we made. In this case, they constructed a tool that allows people to load IFCs and set an array of rules to indicate how to measure the elements to extract the quantities of the model. Like, okay, you should measure the walls like this, you should measure the slabs like that. And once you had the set of measures, you could actually cross this with a price database and get the final price for the building, right? And finally, the final example, many people think, okay, you're building things on the browser, which is probably less powerful than desktop applications. But yeah, of course, this was the case in the past. This is not the case anymore. This is a Rebar model from a bridge, a lot of geometry running at 60 FPS directly inside the Google Chrome. So yeah, in the end, this is probably where we are going. We are going towards the cloud, not towards, the desktop applications that we are familiar with. And many more examples. I don't want to bore you a lot. I mean, we can make any tool with this. We can create a floor plan viewer that allows us to interact with the model, and they take this floor plan and exports the lines parametrically to a DXF where we can actually assign properties to the lines and line type and color and much more. So yeah, and what's next? The project keeps growing. The community is getting bigger. Very big companies are getting involved. We have been contacted by even big companies outside the industry. So yeah, we are very excited to see this, and we hope that hopefully we can contribute to making a change for the better.